So now, let's do multiplication with complex numbers. So let's do negative 7 plus 5i times 3 plus 2i. Okay, let's do this. So how do you solve this? You have to FOIL, okay? Negative 7 times 3, that's negative 21. Okay, negative 7 times 2i, that's minus 14i. Okay, 5i times 3, that's 15i. Right? And 5i times 2i, which is 10i squared. Because it's I times I. I mean, it's 5i times 2i, which is 10i squared. Right? Okay, now we FOILed it. Now we can combine like terms, okay? So first, we need to find our real number, right? Because it's a first, which is your real numbers. Okay, we have negative 21. But we also need to remember I squared equals negative 1. Remember, in imaginary numbers, I squared equals negative 1. So that's 10 times negative 1, right? 10 times negative 1 is negative 10. So that's negative 21 minus 10, okay? And then negative 14i plus 15i, that's plus I. We can just combine like terms. Right, so now we just combine. You have negative 31 plus I. There. So now you know, and this is a standard form of complex numbers, which is your real number and then your imaginary number. This is how you can solve it. The order when you're solving it can be in any way, but your answer needs to be in standard form order. Real number plus imaginary number. Okay, so now let's do division. Okay, plus 7 and 5 minus 1. Okay, 5 minus I, sorry. Okay, so for division of complex numbers, you can never have I in the denominator. So let's write that down. I is never in the denominator, okay? So what you have to do to solve to get I out of here, to get 5 minus I out of here, to get I out of here, is you have to multiply I plus 7. You have to multiply 5 minus I of its conjugate and I plus 7 of its conjugate. Because whatever you do to the denominator, you have to do to the same to the numerator and vice versa. So you take the conjugate of the denominators. What is the conjugate, you ask? The conjugate is basically, all you have to do is flip the sign, right? So this is in standard form, right? Real number plus negative 1i, right? Which is 5 minus I. All you have to do is do 5 plus I, right? So if I had, let's say, 9 minus I, right? The conjugate, right? Conjugate is all you have to do is flip the term. So 9 minus I turns into 9 plus I, alright? So if I had negative 5 plus 12i, the conjugate would be negative 5 minus 12i. All you have to do to find the conjugate of a complex number is flip the sign, this, right? So we need to multiply 5 minus I times its conjugate. So the conjugate of 5 minus I would be 5 plus I, right? Plus I, that'd be the conjugate. So you'd have to do, and you have to, whatever you do to the numerator, you have to do, whatever you have to do to the denominator, you do the same to the numerator. This is 5 minus I, right? So I plus 7 times 5 plus I over 5 minus I times 5 plus I. Okay? So now to solve that, we do FOIL, right? That's what we did right here. Okay, right? So now to multiply, we FOIL, right? I times 5, that's 5I. Here, wait. It's 5I. I times I, that's I squared. Okay. Then we do 7 times 5, that's 35. Plus 35. Then we do 7 times I, which is 7I. 7I. Alright. Don't look at this, it's just scratch work. Right? So we have 5I plus I squared plus 35 plus 7I, right? I times 5, 5I. I squared. I squared, 5I plus I squared. 7 times 5, 35, right? 7 times I, 7I, okay, right? So now we have to simplify to combine right terms, right? I squared, we know, I squared equals -1, right? So this would be 5I plus -1, or 5I minus I. 5I minus 1, right? So -1 plus 35, that's 34, right? Because we need to have our real number first before we have our coefficient of the imaginary number, right? Because of the standard form of the complex numbers. So that's 34, right? And then 5I plus 7I, that's 12I. 34 plus 12I. There, that's our numerator, okay? So now we have 5 minus I times 5 plus I. What we need to do is FOIL, right? 5 times 5, that's 25. 5 times I, that's 5I. I times 5, that's times -5. Negative I times 5, that's minus 5I. Right? And then negative I times I, that's I squared. Okay, so now let's simplify. Oh wait, there's already an equal signs. So I squared is -1, right? So -1 plus 25, that's 24. Right? 5I minus 5I, that's 5I plus minus 5I, that's 0. So what you have is 34 plus 12I over 24, right? But you have to put this in A plus BI form, right? The standard form for complex numbers. So you do, since it's 34 over 20, 34 plus 12I over 24, so you distribute, so 34 over 24 plus 12I over 34. And there, that's how you do it, right? Because you have to keep this in A plus BI form. Sorry, this is supposed to be I, there. I goes there, sorry, because you're multiplying 12 over 34 times I, right? So that's how you put it into A plus BI form. So if you have it here, you don't stop. You have to put it in standard form like this, right? And then you can simplify, right? You need to reduce this, right? Because 2 can go in here and 4, right? So let's actually simplify this, right? So what can go in here? Can 4 go? No, 4 cannot go. 2 can go in. 2 can go though, right? So let's do, right. 2 can go in here, so that's 17 over 12 plus 2 divided by 12 is 6. 34 divided by 2, 17. I. And there you go. That's how you solve division problems. This is the solution of I plus 7 over 5 minus I. There. Shout out to TLS Productions and 18AA. Nice.